Hey guys, my name is Tensor. Welcome to the Dart for Beginners tutorial series. Today we're going to be talking about classes and objects inside of Dart. Before we get started with the tutorial, I just wanted to show you guys that there is a website out here called Dartpad, which you can use to follow along with these tutorials. So even if you do not have Visual Studio Code and the Dart SDK installed on your machine, you can still go to dartpad.dartlang.org, and this is a fully featured Dart runtime environment based off of the Dart SDK version 2.1.0, which is the version that I'm using. They even have some nice samples here. So yeah, I highly recommend you guys check out this site as well as take a look at the samples. Up until now in our tutorial series, I've mentioned objects quite a few times, especially when referring to types, and that is because inside of Dart, anything that you can assign to a variable is an object. So that means things like functions are objects, you have any other type like an integer, a boolean, a string, and even an object is an object. And this means that Dart is, of course, an object-oriented and class-based programming language. Now the type that I want to focus on today is the num type. A num type in Dart is any number, so this means that the number that I've created here called x can be an integer or it can be a double. And this is because the num type is the parent for the integer and the double type. You can kind of think of this like a Venn diagram, where you have an integer type which doesn't include any doubles, and then you have a double type which doesn't include any integers. But then you have the num type, which includes the set of all integers and all doubles. Even above this num type, we have a type called object, which is the parent for all objects inside of Dart. This means that when you create a class, it will automatically be a child for the object type inside of Dart. The main advantage of this is the fact that your class will automatically have some default properties and behaviors attached to it. Now for our example today, we're going to be modeling complex numbers inside of Dart. As a simple rundown, complex numbers are just numbers that were derived from the fact that the square root of -1 cannot be described on your typical real number line. So if you have a real number line denoted by this r, and it goes from -infinity all the way up to +infinity, then if we were to take the square root of -1, it wouldn't appear on this number line. Instead, it would appear on this perpendicular imaginary line. So the square root of -1 is equivalent to the letter I, or 1i, and then I squared is equivalent to -1. This gives rise to the idea that you can create multiple different imaginary numbers. So here I've got an imaginary number that is 5, which is the real component of this imaginary number, plus 2i, which is the imaginary component of this number. And then I've got the real number 10 written as an imaginary number. And of course, since it's a real number, it doesn't have an imaginary component, but we can write it as a complex number by writing 10 plus 0i. And then of course, we can have imaginary numbers or complex numbers without reals attached to them. And these numbers can be described on this Cartesian plane. So for instance, say we have that 5 plus 2i number that we were looking at before. If the real number 5 appeared, say, here, and then the imaginary number 2 appeared around, say, here, then the number 5 plus 2i would appear somewhere around here, where these two lines intersect. Anyway, if you want to learn a bit more about complex numbers, then there are quite a few good tutorials that are floating around on YouTube, and I'll link a few resources in the description of this video if you guys are curious. Alright, so let's go ahead and create a class called complex. To get started modeling complex numbers inside of Dart, we want to add some data to this class, and we can do this by creating what are called fields. Here I've got the field real and the field imaginary, and both of them are num type. So when we create a complex number object, that complex number object will have a real and a imaginary field associated with it. By default, any class you create inside of Dart has a constructor, and the constructor is just a function that gets executed, which will then create an instance of that class. So in this case, I'm just creating a complex object by saying var_c equals complex. And I can go ahead and assign these fields values for this particular instance of this complex number by calling C and then using a dot operator and then typing in the name of the field that I want to assign to. So here I'm saying c.imaginary equals 2, and then I'm saying c.real equals 5. Now I can go ahead and print out these two fields by and then print out the object itself. And here you can see that the real component is 5 and the imaginary component is 2. But if we print out the actual object, it just says instance of complex. And that is because the complex class does not have an explicit toString method. Instead, it has the toString method that it inherited from the base object class. And I know this concept's a little bit hard to understand at first, but just bear with me. As I mentioned before, all classes that we create inside of Dart automatically get some behavior from the object parent class. In this case, the main behavior that we're worried about is the toString method. And as you can see here, we can go ahead and override that toString method. And this is actually what the toString method looks like currently inside of our complex class. Notice it's saying return super.toString. What this is doing is it's basically saying call to the parent of our complex class, which is the object class, and then execute its toString method. And that's where we get that instance of complex string when we print out a version of our complex number. We can go ahead and replace this method with our own method. And all we need to do is follow the basic shape of the other toString method. That is to say that it takes in no parameters and it outputs a string. So here I've created a toString method for our complex number type that will print out the complex number so that it will look like this format up here. We check to see if the imaginary number is negative or positive, and if it's positive, then we want to print out the real number plus the imaginary number times I. And then if it's negative, we want to print out the real number minus the imaginary number, absolute value, times I. Now the reason we're calling the absolute value method on the imaginary number here is so that we do not have two negatives. Say we have 0 minus 4i as our complex number. If we didn't call the absolute value here, it would be 0 minus 4i instead of 0 minus 4i. Now, of course, we can go ahead and execute our program, and you can see here, instead of saying instance of complex, now we actually get the complex number format because it executes our toString method. One of the other methods that is by default attached to all objects inside of Dart is this double equals operator. And this, of course, checks to see the equivalency between two objects of the same type, in this case, two complex objects. Now, by default, it checks to see the equivalency by checking what's called the hash code, and this is something that's a little bit advanced and something that we'll talk about later. But in our case, because our complex number actually has numerical values inside of it, we can use those numerical values to check to see if our two complex numbers are the same. So our operator equals to returns a boolean, and it takes in the item that we're comparing to. We want to run an if statement to check to see if the item that we're comparing to is complex or not. And because we can only say that the other is a complex type, we want to negate that statement. So if the object that we're comparing to is not a complex object, then we'll return false. Otherwise, we'll return the result of this conditional statement where we check to see if this real is equal to the other's real, with this being the object that we're calling this operator on. And then we also check to see if this imaginary number is equal to the other's imaginary number. So now inside of our main function, I can go ahead and instantiate another complex object. And in this case, instead of calling c.imaginary and c.real, I'm using what's called the cascade operator. This is just a bit of syntactic sugar, which allows us to combine all three of these lines into one single line. So we're just saying, create the complex object, then assign the imaginary field to 2, and then assign the real field to 5. And now we can check to see if these are actually equivalent to one another, which they should be, and this should then print out true. So as expected, we get back true, and then of course we also get back 5 plus 2i, and then 5 plus 2i. Now, even with these cascade operators, this is still not really an efficient way to construct an object. So as our complex object currently is, we can instantiate the complex object with no values inside of it, and we can print it out. And when we do this, we actually get a unhandled exception because it tries to print out a value that is null. So this is not good for our complex number. We can fix this by creating a constructor function inside of our class. And this constructor function is behavior that allows us to define how we want our objects to be instantiated. So let's say we create a constructor which takes in two nums, one called real and the other one called imaginary. Now our complex number needs to have a value that is real and a value that is imaginary. And inside of the body of this function, we can go ahead and assign the parameter real to the field real and the parameter imaginary to the field imaginary. And I'm doing this using the this keyword, which you saw down here inside of our equals to operator. The this keyword essentially just says I'm referring to this object, as in the complex object that we're working with currently. So when we create an instance of this complex object, we're just saying, all right, these are the parameters, these are the numbers that the user is passing in, whereas these are the fields that are attached to the object itself. I know this can be a little bit difficult to understand at first, but as you work with it, it'll start to make a little bit more sense. Now if we come back up to our main function, you can see here that we are starting to get errors where we're instantiating these objects because they're expecting 2 arguments inside of them by default. So let's go ahead and correct that. And as you can see here, we get back false because they're not equal to one another. And the first one is 2 plus 5i and the second one is 5 plus 2i. Now this constructor here that we just created is a little bit verbose, and it's also a constructor pattern that you'll see a lot inside of objects. So Dart has some syntactic sugar that you can use to actually clean it up and make it much smaller. You can just say complex, and then you can just pass in this dot real and this dot imaginary. And all this really says is that to create this object, we need a value for this dot real, which will be the first argument in the constructor, and then we need a value for this dot imaginary, which will be the second argument in this constructor. It's essentially the same as this constructor here that we just created, except we do not have to create specific parameters here, and we don't need to specify a body here. So we've got our complex object type and class to a point that is pretty nice. But let's make it so that we can set up complex numbers like this and like this without having to pass in 2 parameters. So we can just pass in 10 if we want to have a real complex value, and then we can just pass in -4 if we want to have a imaginary complex number. We can do this using what are called named constructors. Now these named constructors are actually set up in a way that is incorrect. You can see here, we're creating a new constructor, and this actually will construct a new object from the complex class type. And this constructor is named real, so we just call complex.real, and then we pass in 1 argument. In this case, it's a number type. And then it calls to the primary constructor, and it passes in real and then 0 for the imaginary field. And then we have the same happening for the imaginary field. This syntax is completely incorrect. When we call to this named constructor, it creates the object, and then it calls to the other constructor, which then doesn't properly execute. So we need a way of calling to this constructor before the object is actually created. We can do this by way of what's called the initializer operator. You can see here it's just a colon, and this says, all right, if you call complex real the named constructor, you take the number value that's being passed in as the parameter, and then you call this, which then refers to this constructor up here, and then it passes in these two values for this constructor, and then the object is created afterwards. So it's almost like this constructor here is just an alias for the primary constructor, except we're always going to be passing in 0 for the imaginary field if we call to this constructor here. If you're going to use the initializer, you need to use the this keyword, otherwise you'll get an error. And you can see we do get an error from just calling to the complex main constructor. So we just replace this with this, and now it will work properly. And now, like with our primary constructor, we can just call to our named constructors inside of our main function and put them into variables. R equals complex.real, pass in 10, and this will then create a complex number where we have 10 for the real component and then 0 for the imaginary component. And then we can do the same with complex.imaginary and -4. And of course we can print all of these out as well. So as you can see here, we do get our two new complex numbers printed out, and they do have 0 for the imaginary number and 0 for the real number respectively. So named constructors can be pretty powerful because they can give us alternative ways of creating certain types of objects. We can sort of constrict the rules for these specific types of objects. Now let's take a look at getters and setters inside of classes. Now in Dart, if you want to make an object private, meaning it's scoped to the block of code that it's inside of, you put an underscore in front of its name. So if we want to do that with the two values inside of our class, we can just say, all right, well, the value for real will have an underscore in front of it, and then the value for imaginary will also have an underscore in front of it. This means that theoretically, if I was to write c._imaginary and set it equal to 10, this wouldn't work. Now, of course, you can see we're not actually getting an error because it's working. And the reason that it's working is because our class and our main function are inside of the same exact file. Typically, when you create a new class inside of Dart, you would want that class to be inside of its own file. And if it's inside of its own file, then the underscore makes the variable or the entity, whatever it is, private. So let's just pretend that our class for the complex numbers is inside of its own file. So this will not work, which means that we cannot directly grab the imaginary number and change it by simply just calling c._imaginary and setting it equal to 10. We can create a bunch of methods called getters and setters, which will allow us to then access these values. So here we have a function called getReal and a function called getImaginary, and this will then allow us to get the values from this object. This will return a number value, and then it just returns the real field. And the same goes for our getImaginary method. Then we have two void functions, one called setReal and the other one called setImaginary, and these take in a number parameter which then gets pushed into the object's field. So now I can go up into main and I can go c.getReal, and this will grab the real field from the C object, and then I can also run c.setReal, and then this will go and it will set the real field in the C object and change it. There are various reasons why you would want things to work this way, why you would want specific getters and setters, and why you would want fields to be private. I'm not going to go over those reasons in this specific video. I'm just showing you guys that this is possible. Dart does come with some nice syntactic sugar to make all of this a lot easier because it's something that's pretty common inside of classes. In Dart we have keywords for get and set, which then allow us to create the same types of functions. So here I can say get real, which will get the underscore real field, and then I can say set real, which will take in a number value and put that into the underscore real field. And of course I can do the same thing for our imaginary field. And you can see here both of these functions actually have the same exact name because Dart knows that they're either a getter or a setter. And I can call the setters, for instance, like this. So I can just call i.imaginary and set it equal to 20. And this is like I'm setting the field equal to 20 instead of actually calling a function. And I can do the same for the real setter. And then to call the getters, I just call i.real and then i.imaginary. And again, it's like I'm just dealing with the field directly, but instead I'm dealing with a special syntactic sugar over a function. And you can see here I've printed out the two getters, and then I've also printed out the changed number where we have 50 and 20 for the real and the imaginary values respectively. Alright guys, well that's it for part 1 of our class tutorial. If you like this tutorial, feel free to subscribe and like. If you have any questions or comments, feel free to leave them in the box below. And if you dislike this video, then by all means downvote it as much as you like. Have a good night.